All right, so let's stop debugging and review what we have experimented with so far with our input-output and conversion programs that we tried. So right here, this is another example of conversion from a buffer to actually from 16-bit signed integer to a string. So I'm just going to remove this from our program, and just a quick review that here we demonstrate how to create an output, how to create an input. We also demonstrate how to measure the size of input by the user. We also demonstrate how to convert a 32-bit signed integer such as register EAX to a string of characters. So there is no need to check for anything. This is called double word or integer to ASCII conversion. Then we also demonstrate how to input something that is a numeric input, like an integer input. And then we use the macro that's called ASCII to double word and provide the buffer, and the result comes out in EAX. If everything is okay, the text is converted to an integer. So these are very, very typical type of conversions required that are accommodating those input and output needs to display and convert internal formats of our integers. In our case, we just entirely focus on 2's complement formats. Now, these are conditional jumps. So since A to D sets an overflow flag, in case if something is bad, then we can use JO, which means jump if overflow, or JNO, which stands for jump if no overflow. So we say that let's check overflow flag, and we can actually replace this here. That would be like a pseudocode if overflow flag is does not equal 1, right? So which means is not set. In other words, we can say that if overflow flag equals 0, right? If overflow is 0, then jump, right? And we're jumping forward, jump forward. Okay, jump forward, and we're jumping to this anonymous label. So this is saving us from coming up with something like everything is okay. So this is kind of boring and difficult to read. Instead, you just use anonymous label, and you can jump forward if you want to, and you can jump to this anonymous label. Likewise, if this condition is not true, so we can say here that everything is okay, jump forward. If not okay, then we're printing error message, which is defined somewhere in our constant data segment. And then we print new line, and we go back to the original prompt. So we try to handle user input errors with these conditional jump if no overflow flag. Now the next slide here explains all the rules in details that apply to ASCII to double word. So I'm not going to read this aloud. You can just check these rules on your own. But we should be armed with enough tools in our toolbox to be able to see what this lab challenges are. So I'm just going to jump forward to the laboratory assignment right here. So I think we have enough demonstrations right here that we can start programming this next lab assignment. So this lab assignment is asking us to do the following. Write an assembly program that inputs two 8-bit unsigned integers from the user, calculates the sum of them, and prints the result on the screen. Then the second part of our laboratory is to input two 32-bit signed integers from the user, calculate their difference, and print the result. Make sure that the program handles every possible error condition, so that's important. We just want to make this program bulletproof. Just make sure that the program handles everything, and that could be specific to bad input formats, of course, and any kind of sum and difference overflow conditions we should also be able to detect and report. In case of an error, have the user retry the input and repeat the calculation. So that's just similar to what we tried over here, that we try to repeat something and let them re-enter the integer that we're expecting in our program. All right, so this is a few of these macros that we can definitely use to solve this laboratory exercise. In case of an error, have them retry. Every CPU instruction in our program has to have a brief comment, otherwise we have this bad, nasty deduction of 15 points. And we need to be able to submit the resulting source code as a result of this lab. Okay, so let's get started. And this is a nice demo of all the macros that we potentially may need here. So I'm actually going to save this program, right? File, save this program as, and just use M08 macro demo. Okay, so I'm just going to save this program and use it as potential just to look up the formats of the input buffers, memory buffers, all formats, so we can copy and paste from this code. And then we're going to go back to Solution Explorer. That's very important. After making a copy, we're not going to modify this program. We really have to jump back to the original M08 code, right? And we're going to continue modifying this M08 and use this macro demo just as a reference, a nice example of all the macros that we will definitely need to be able to finish this lab assignment.